Hi, my name is Joe Tapper, and I run a small refrigeration company, and I've always had a passion for teaching. Um, and I've been not up against, but I need to teach one of my good, employees the principles of refrigeration, and I started making a list of things he needs to know and blah blah blah, and I thought it'd be useful for a lot of people to hear this kind of thing because there's not a lot of it on YouTube. I've noticed. Okay, so we're going to be talking about refrigeration, and I think the first question that comes up is, what is refrigeration? I'm glad you asked. I've heard a lot of definitions of refrigeration, but when I sat down and thought about it, I came up with the answer. Basically, you are using electric motors to pump heat out of a conditioned space, out of a system. Okay, so you've set up a system where you have several electric motors that are doing various things to pump heat from a conditioned space to outside of that conditioned space, okay, into what we call the ambient, or just outside, okay. You've heard of some of these things, all these various fan motors, evaporator fan motors, condenser fan motors, the compressor itself. All of them are electric motors, just like you see all the time. Your fan that you turn on, the one that's right behind me in this video, that's an electric motor, and it's very similar to what is used in at every step of the process. This is a simple shaded pole motor probably in this fan that is indicative of 90% of all the motors in refrigeration technology. Okay, so we're talking about, if you have a simple grasp of electricity, that's going to be par for the course for refrigeration, obviously, as any experienced refrigeration tech knows, and hopefully you will come to know over the course of these, hopefully to be more than one video. This is the first one. But yeah, what we're asking is, what is refrigeration? And my answer to you is that refrigeration is using electric motors to pump heat from a conditioned space, like the inside of your refrigerator, to an unconditioned, outside, pumping heat. Okay. And I think the next natural question that everybody asks about refrigeration is, what is refrigerant? Okay. And refrigerant is the conduit, basically. It's the conduit through which we are pumping the heat. We are using refrigerant in a circular motion inside of a closed system, okay, and manipulating it and it's all about change of state. All right, bear with me. You're pumping refrigerant in a circular system, and you're doing specific things on each end to change the state of the refrigerant from a liquid to a gas, from a liquid to a gas, over and over again. Okay? You are taking advantage of the laws of nature to do the not the dirty work, but like we're purposefully we're taking advantage of what we know about these chemicals and subjecting them to certain pressures at certain times in the circular motion to absorb heat on one end and reject it on the other. Okay? The refrigerant is the conduit through which heat energy flows between the conditioned space and the unconditioned space, the ambient space. And at each end, both where it's absorbed, the heat's absorbed, and where the heat is dispelled, we have a change of state in the refrigerant, like going from a liquid to a gas in this case. All right. So we have a circular flow of refrigerant going from one side to the other, back over and over again. We're going to a liquid, changing to a gas, liquid, gas, liquid, gas, condensing, evaporating, condensing, evaporating. And this change of state in the refrigerant is the property of the chemical itself that we are taking advantage of to move energy from the conditioned space to the ambient, to the conditioned to the ambient. And we're applying these electric motors in a very specific way to do, I guess, three things. To keep the flow going with the compressor, to reject the heat on one side, and to absorb the heat on the other side. You know, there's a reason we are evaporating here, condensing here, and there's a reason that inside your house, inside at your business, you have your evaporator that's inside of your unit or inside of your air conditioning or your walk-in cooler. That's called the evaporator because you are evaporating the refrigerant. And outside you have your condenser, and it's condensing refrigerant back into liquid. Okay, and it's condensing it, and then the compressor makes it flow back inside to evaporate again. Okay, and once it evaporates, it goes back and it condenses again. It's the refrigerant itself is in a circular loop. It's never consumed if it's properly installed. It never leaks. It just keeps going. As long as these motors are doing their thing, nature is not going to change. Okay? The laws that govern whether or not these things evaporate or condense or whatever were set in stone a long time ago. Okay? So as long as this system is properly maintained, you will get this flow of heat from your conditioned space to your outdoor ambient space. Okay? Now, how that system works is, the whole, there's a lot that goes into, properly installing and maintaining an air conditioning system or heating, or, the whole thing. But just the basic idea, okay? I guess there's two ideas here. What is refrigeration? You are using electric motors to pump heat from your conditioned space to outdoors, okay? And the other idea is that you are using refrigerant you're manipulating refrigerant in a circular motion from indoors to outdoors, and not only refrigerant. Most people say refrigerant. I almost did too, but it's really the change of state in refrigerant. You're changing the state of the refrigerant indoors by evaporating it, and then changing the state outdoors by condensing it. That is actually the meat and potatoes of where your energies are being, why they're flowing. With the bulk of the energy that goes into these things on either end goes into the change of state on each one. For your chemistry buffs, if you remember those graphs of like water, when you keep adding heat to it, the heat of the water as it's a liquid keeps going up and up and up and up and up, and then once it hits 212, it just stays, you know, as you keep adding heat, the temperature stays the same, and then once it turns to steam, it goes up and up and up. But like really, the bulk of that energy, the temperature was the same. It was like the heat of transformation, or whatever they call it. Um, the most the meat and potatoes of moving energy throughout a system in refrigeration is involved in the change of state. And it's no coincidence that the major components of a refrigeration systems are called the condenser and the evaporator, because you are condensing and you are evaporating. And those are words that you're familiar with, hopefully, with changing state of, you know, materials, any material, or, you know, water. Condense water, it's dew. You know, you evaporate water, you are creating steam. So anyway, this is the first one. I hope to make many of these videos and get people to be excited about refrigeration, especially my employees. But for now, I think it's enough, and good night.